Yeah, hi. I thought I'll let someone else talk about dragons. That it's somehow for everyone clear what a dragon is. So let's have a listen to Andy Hall about dragons.
Before we close this chapter, let's consider what a dragon looks like. In myth, references to dragons can be confusing because sometimes they boil the sea, sometimes they ravage the land, and sometimes they take wing. The discharge that scraped the land in surface conductive arcing also created its own weather and induced following jet stream winds. Depending on perspective, one might describe a dragon as a submarine, serpent, or flying demon. Following jet stream winds, choked with dust swirling from cyclone to cyclone, had to look like animate serpent bodies glowing with internal lightning. In its early path, it scraped the Earth's surface, following surface water laid down by storm and tsunami. Water is its conductor. Just as in the atmosphere, water is the conductor, like it is in our bodies and plants and pretty much all of nature. Water is dipolar, and in the field of a strong electric potential, the polarity of its molecules align coherently and facilitate current. It's liquid, so it flows through pores in rocks and soil, providing electrical continuity across vast stretches of Earth. Earth's crust is saturated with water, even deserts, but for the very shallow top layer of sand and mountain. Water provides the surface conductance for the ground-to-ground discharge, so that's another rule of the dragon, to follow water. But it doesn't always follow surface water. The storm that drew forth the storm over the Colorado Plateau, was laying down layer upon layer of dry sediments, burying lakes, inland seas, in their drainage. The dragon burrowed into the ground beneath these dry deposits and followed the water like a tree root.
Yeah, that was Andy Hall talking about dragons. What they really are, and why everybody still seems somehow to understand to be scared of a dragon. Mm, if we watch Windy, as we can see, like this whole area, probably even down here, there's like really vast regions with rain and thunder. Like really big regions. And if you go over to volcanoes and earthquakes, yeah, there's obviously something going on in Europe and many other places too. Like the red ones are the shallow, greens are a little bit deeper. Like first is red, then orange, then yellow, or something like that. That's a deep one. 210 kilometers. Blue one is not that deep. 179. So when we go over to ISFA and watch at the magnetopause, this is the bow shock. Here's the sun, and like that's night, that's day. And Earth is this. And like this bubble is protecting us from being not burned alive, keeping the oxygen and the whole rest of the atmosphere in place. But it is weakening, and North Pole is going down here. South Pole is moving a little bit upwards. So there is more stuff coming in either way. We have those big cycles of the sun, 12,000 years, 6,000 years. The last time big stuff went down on Earth was about 12,000 years ago. And yes, it's a cycle. So every 12,000 years, something's going to happen. Last time, the Alps got created, for example, or even the Grand Canyon, or altogether. My plasma rocks. I interpret this picture here that there is energy going in and out at the equator, which is probably not too good. We are getting earthquakes and stuff like that. Volcanoes break out. Yeah, time is missing. 6 hours. Why is time missing in a model? You know? That's like human generated computer stuff. This doesn't look like that in the actual world, you know? You probably wouldn't see it. I don't know. So, like, if our bow shock goes, like, if that's our magnetic, that's a sphere, you know, it's cut through. It's basically like, this would be a drop like figure. And that's Earth in the middle of the drop. And this is here. It's basically like the parrot instability, which is a torus-like structure, which has this ring around it, and it goes down and but if you cut it in half, you get Stickman. So that's 2D. But anyway, I leave it here. Thanks for listening.